Assalamu alaikum, dear student. This is Muhammad Mahwalam, lecturer in chemistry, English medium day shift, Rajaputra Model College. Today I would like to deliver a very important lecture on organic chemistry. This is my fifth lecture. For the first time in this lecture, I would like to say something about aldehyde and ketone. Okay, if you want to know about aldehyde or ketone, for the first time you have to know about carbonyl compound. Okay, so carbonyl compound are basically aldehyde or ketone, the compound that contain just this group. Okay, this type of compound is basically called carbonyl compound. Now I would like to say something about the hybridized structure of this compound, of this group. This is basically the hybrid structure. Both carbon and oxygen in this structure are sp2 hybridized. As they are sp2 hybridized, there must have a perpendicular p orbital, and by using this perpendicular unhybridized p orbital, they form a carbon oxygen pi bond, and by using these two hybridized orbital, so there is a sigma bond in between carbon and oxygen atom. So this is basically the structural formula of this group. Okay, as both of them are sp2 hybridized, so the bond angle in between them should be 120 degree and the structure must be planar. Now I would like to say something about nucleophilic addition reaction. If you analyze this structure, okay, as oxygen is electronegative element, so oxygen will become partially negative in charge and carbon will be partially positive in charge. So nucleophile should be attacked here. Nucleophile should be attacked to this carbon. Okay, you can consider this example. This is basically nucleophilic addition reaction. Cyanide as a nucleophile should attack to this carbon. By this way, oxygen will be negative in charge as it is electronegative, you know. So after formation of this product, then proton, this oxygen as negative in charge, it will receive this proton and this product will be produced. Okay, by this way, this type of nucleophilic addition reaction can be possible in case of carbonyl carbonyl group containing compound. Okay, now I would like to say something about the reactivity order of nucleophilic addition reaction for different types of carbonyl group containing compound. For example, methanol, ethanol and propanol you have seen in the board. Which one has greater reactivity order? The reactivity order in case of nucleophilic addition reaction basically depend on the positive induction effect. The greater the positive induction effect, the lesser the reactivity order towards nucleophilic addition reaction. Okay, if you consider these three structure, okay, in case of propanol, there are two methyl group is attached to this compound, there are one methyl group is attached to this carbon, and there is no methyl group attached to this carbon. Okay, as methyl group can act as a electron donating group, so their positive induction effect is possible, and their also positive induction effect is possible as their two methyl group is possible. So this carbon will be less reactive towards nucleophile than this carbon, and as their presence no methyl group, so there has no positive induction effect, so this carbon will be more effective, more reactive than towards nucleophile. So for this compound methanol, it will undergo nucleophilic addition reaction rapidly. So that's why this type of reactivity order can be possible. So methanol has higher reactivity order than ethanol, and then ethanol has higher reactivity order than propanol. So now preparation of aldehyde. You can prepare aldehyde from alcohol and alkyne. There are a number of processes to produce basically aldehyde. I just explained two processes. From alcohol, if you want to prepare aldehyde, you must have to oxidize alcohol. Okay, you know very well, any alcohol if you oxidize by using a oxidizing agent, then it will be converted to aldehyde. Okay, here I use potassium permanganate in addition with potassium hydroxide as a oxidizing agent, and thus it supplies nascent oxygen or active oxygen, and by this way this alcohol is oxidized and converted to aldehyde. Now the second process, it is from alkyne to ethanol. This is basically water addition reaction also, you can say. For the first time you have to use 2% mercuric sulfate and 20% sulfuric acid, then water will be added to this compound, and by this way this type of compound will be produced. This compound is called enol type compound, and after the rearrangement of enol type compound, it will be converted to aldehyde. Now the preparation of ketone, you know very well, from 2 degree alcohol, this is very easy to produce ketone. This is very common process. Okay, if you want to prepare this type of aldehyde, you also here you have to oxidize this 2-degree alcohol to convert ketone. By this way you can also produce aromatic ketone. This is basically acylation reaction, right? Electrophilic substitution reaction I have already discussed in one of my lecture. So by this electrophilic substitution reaction you can produce aromatic ketone. At the same time, by the oxidation of 2-degree alcohol you can produce ketone. So dear student, now I would like to say something about the identification of carbonyl compound. What are basically the way to identify the carbonyl compound? The test of 2,4-dinitrophenylhydrazine is a very important test to identify carbonyl compound. So for this test, for the first time you have to take 5 to 6 ml carbonyl group containing compound, either it is aldehyde or ketone, in a test tube. Okay, then you have to add this compound. The name of this compound is 2,4-dinitrophenylhydrazine. Okay, so you have to add 2,4-dinitrophenylhydrazine in this test tube which contain carbonyl group containing compound. Okay, when you add this, then after some time there will produce a yellow precipitation. Okay, there will produce a yellow precipitation of this compound. The name of this compound is 2,4-dinitrophenylhydrazine. Okay, so oxygen and hydrogen, by the combination of oxygen and hydrogen they produce water. Okay, and then this compound will be produced which has the color yellow precipitation. From this yellow precipitation, then you will be sure of that this compound, the compound that you have taken in the test tube, this compound must contain carbonyl group. Either it is aldehyde or ketone. It can be aldehyde or ketone, but it must contain carbonyl group. So test to identify carbonyl group, you must have to make sure the reaction, you have to test it by using 2,4-dinitrophenylhydrazine. So dear student, now I would like to say something about the confirmation test for aldehyde. You can confirm aldehyde by using two reagents. One is toluene reagent, another is Fehling reagent. Okay, for the first time, what is toluene reagent? Toluene reagent is basically silver diamine hydroxide is called toluene reagent. When you add toluene reagent with a solution of this compound, then they produce a silver mirror. Then they produce a silver mirror on the wall of the test tube. You will clearly see your face. Okay, by using this silver mirror. In addition, with they produce a ammonium salt of acid, ammonia, and at the same time water also. So this is basically an oxidation and reduction reaction, and this toluene reagent here acts as a oxidizing agent. You can easily understand that this here act as oxidizing agent. The oxidation value of silver plus is here +1, right? And this is converted in the product. In this compound, the oxidation value of silver is 0. So basically this toluene reagent get reduced in this reaction, and by the reduction of this toluene reagent, this is converted to silver, and by this way their silver mirror is produced here. At the same time, ethanol as a reducing agent, it become oxidized, it get oxidized, and by the oxidation of this ethanol, this is converted to the acid, and due to the presence of ammonia, this is converted to the ammonium salt of acid. Okay, and they produce also ammonia and water. So the main point is here that by the production of silver mirror here, you will be sure of that there must presence aldehyde. Okay, ketone does not give this type of reaction. Now Fehling reagent, basically basic cupric hydroxide is called Fehling reagent. When you add Fehling reagent with a solution of this compound, then they produce a cuprous oxide. They produce a reddish brown precipitation of cuprous oxide. From this reddish brown precipitation of cuprous oxide, you will be sure of that there must presence aldehyde. Okay, here this Fehling reagent also acts as an oxidizing agent, and that's why the oxidation value of copper here is +2, and the oxidation value of in this compound of copper is +1. So this compound get reduced, and the oxidation value has been changed to +2 to +1. Okay, and ethanol here act as a reducing agent. For this reason it gets oxidized and converted to this salt of acid. Okay, so by the production of reddish brown precipitation of cupric oxide, you will be sure of that there must presence aldehyde. This type of reaction is not possible in case of ketone. So by using tolerant reagent and failing reagent, I can easily understand either their presence aldehyde or ketone. If it is aldehyde, this type of is possible in case of only for aldehyde, but in case of ketone this is not possible. Now what is basically the way to identify ketone? Okay, if you want to identify ketone, you have to make sure the reaction of iodoform reaction. I have already discussed iodoform, haloform, chloroform reaction in my previous lecture 4. So if you want to identify ketone, you have, for the first time you have to take a ketone, a solution of ketone in a test tube. Then you should add your iodine in addition with sodium hydroxide as an alkali. When you add this in this test tube, they are produce U-loop precipitation of iodoform. They are produce U-loop precipitation of iodoform in addition with this compound. Okay, with the production of the U-loop precipitation of iodoform, the production of U-loop precipitation of iodoform indicates there must presence ketone, okay, or propanol, right? So by this way you will be sure of that to identify the ketone. So by using tolerant reagent or failing reagent, you can easily identify aldehyde. By using iodoform reaction, by the process of iodoform reaction, you will be able to identify ketone. So for the first time you have to identify carbonyl compound. I have already discussed in my previous slide that to identify carbonyl compound I need here 2,4-dinitrophenyl hydrazine. By using this I will be sure of either their presence carbonyl compound or not. Okay, after finding here carbonyl compound, then I have to make sure this compound is either aldehyde or ketone. If this is aldehyde, then it will be react with tolerant reagent and failing reagent. It will give tolerant reagent test and failing reagent test. Okay, if it gives this test, then it will be aldehyde, I will be sure of that, and if it is not, then it will be ketone. Okay, again I can also identify the ketone by using this reaction. So dear student, now about carboxylic acid. This is basically the preparation process of carboxylic acid. You can prepare carboxylic acid from alcohol. You know it very well. I have already said when you oxidized alcohol by using oxidizing agent, for example potassium permanganate in addition with potassium hydroxide, then it will be converted to aldehyde, right? If you further oxidize this aldehyde by using this oxidizing agent, it will be converted to acid. At the same time, this is aromatic alcohol, right? The name of this compound is benzyl alcohol. Okay, when you oxidize this benzyl alcohol, then this portion will be oxidized by using a oxidizing agent. Then this portion will be oxidized and converted to CHO. I mean to say this benzyl alcohol will be converted to benzaldehyde. If you further oxidize this benzaldehyde, then it will be converted to benzoic acid. So by this way this is easy. If you want to convert alcohol into acid, just you have to make sure have the oxidation reaction. Okay, now the second process, you can also prepare acid from the hydrolysis of cyanide. Okay, so this is methyl cyanide. You have seen, if you hydrolyze the methyl cyanide in presence of a slight amount of acid or base, if you hydrolyze this methyl cyanide, then this cyanide portion will be converted to C double, this C will be converted to COOH, and this N will be converted to NH3. So when you hydrolyze the cyanide compound in presence of a slight amount of acid with a little bit heat, then this cyanide type compound will be converted to acid. This portion will be converted to COOH. By this way you will get CH3COOH, and this nitrogen will be converted to NH3. At the same time, in case of aromatic cyanide, this is also possible to convert into benzoic acid. Okay, from Grignard reaction, by using Grignard reagent, this is also possible to produce acid here. In that case you have to use carbon dioxide. there you have to carry out the reaction in presence of carbon dioxide with the Grignard reagent. You know, methyl magnesium bromide is the Grignard reagent. When you use this methyl magnesium bromide as the Grignard reagent, this portion is negative in charge and rest of the portion is positive in charge, and this carbon is positive in charge, you know, as oxygen is attached with this group. Okay, then this methyl group will attack to this carbon. By this way, this type of product will be produced after the hydrolysis of this compound in presence of a slight amount of acid. Then this portion will be converted to OH. By this way, this converted this product will produce this product. Okay, ethanoic acid. So when you make sure the reaction of carbon dioxide and Grignard reagent methyl magnesium bromide, then you will be able to produce here ethanoic acid. So these are the process to produce basically carboxylic acid. First process is from the oxidation of alcohol, second process is from hydrolysis of cyanide, and third process is from Grignard reaction or by using Grignard reagent. So dear student, now identification of carboxylic acid. If you want to identify carboxylic acid, you have to add sodium bicarbonate or sodium carbonate type compound with this compound. If you add sodium carbonate or sodium bicarbonate compound with this type of compound, then they are produced carbon dioxide gas. They are evolved carbon dioxide gas in addition with sodium salt of carboxylic acid and at the same time water. Okay, the production of carbon dioxide gas will be confirmed by the addition of calcium hydroxide. If you add here calcium hydroxide as lime water, then this calcium hydroxide will be converted to calcium carbonate, which make this lime water little bit milky. And through this reaction you will be confirmed that in this reaction there must produce carbon dioxide. At the same time, as it is a gas, they are produced bubble, right? So from the bubble, at the same time, from this reaction, the production of carbon dioxide will be confirmed here. Okay. Now, if you want to identify formic acid, you know formic acid is the first member of carboxylic acid, right? If you want to identify it, if you have to add here mercury chloride. Okay. If you add here mercury chloride, that produce carbon dioxide, hydrochloric acid. At the same time, mercurous chloride, white precipitation of mercurous chloride will confirm the presence of carboxylic acid. When you add this carboxylic acid, this formic acid with mercury chloride, okay, white precipitation will be confirm it. So dear student, now I would like to prepare 1 degree, 2 degree, 3 degree alcohol from Grignard reagent. So what is Grignard reagent? Alkyl magnesium halide. Alkyl magnesium halide is called Grignard reagent. Okay, if you want to 1 degree alcohol, you must have to use methanol. Now the point that should be noted in that case, if you want to prepare 1 degree, 2 degree or 3 degree alcohol by using Grignard reagent, you have to use as reactant aldehyde or ketone, either aldehyde or ketone. During the time of formation of 1 degree alcohol, you must have to use here methanol. Only methanol you must have to use in that case. Okay, as carbon oxygen bond, this is a carbonyl group, you know. So oxygen is electronegative, so the bonded electron will shift towards this oxygen and this carbon will be positive in charge. And methyl carbanion, okay, in methyl magnesium bromide, this is basically her Grignard reagent, you know. This portion in Grignard reagent, this portion will be negative in charge. You have to remember this point, and rest of the portion will be positive in charge. Okay, so methyl carbanion as a nucleophile attack to this carbon. When it attack to this carbon, then this type of product will be produced in that case. Okay, then you have to hydrolyze this portion by using a slight amount of acid. If you hydrolyze this portion, then this portion will be converted to OH. By this way you will get CH3 CH2 OH. So this is basically the product 1 degree alcohol. Now I would like to say something 1 degree alcohol. What is 1 degree alcohol? The carbon that is attached with the functional group OH, if it is attached with a single number of methyl group, this type of alcohol is called 1 degree alcohol. Now 2 degree alcohol, again say if you want to prepare 1 degree alcohol, you just use as reactant methanol. From methanol you can easily prepare 1 degree alcohol. Rest of the aldehyde except methanol you can use to prepare 2 degree alcohol, only 2 degree alcohol. Okay, you can take propanol, you can take ethanol, you can take butanol, rest of any kinds of aldehyde you can take to prepare 2 degree alcohol. Okay, if you use here to ethanol when it react with grignard reagent methyl magnesium bromide, then this type of product will be produced. This type of product will be produced just like as the mechanism of 1 degree alcohol, and then you have to hydrolyze this portion by using a slight amount of acid, then this portion will be converted to weight. Okay, so these will be the product. So what is 2 degree alcohol? 2 degree alcohol is alcohol where the carbon that is attached with the functional group OH, it must attached with 2 alkyl group. Okay, 2 alkyl group. This type of alcohol is called 2 degree alcohol. Now 3 degree alcohol, if you want to prepare 3 degree alcohol, you cannot take here aldehyde. Okay, you must have to add here ketone. Without ketone, this is not possible to prepare 3 degree alcohol. Okay, when ketone react with methyl magnesium bromide as a Grignard reagent, then the mechanism will be same just like as before. Okay, this type of product will be produced after you make sure the when you hydrolyze this portion, then this portion will be converted to OH, and by this way this type of product will be produced. The carbon that is with the functional group OH, it has 3 methyl group. Okay, as it attached with 3 methyl group, this type of alcohol is called 3 degree alcohol. So by this way you can prepare 1 degree, 2 degree and 3 degree alcohol by using Grignard reagent. The point that must be noted in that case, to prepare 1 degree alcohol, you have to use her methanol, the first member of aldehyde. And if you want to prepare 2 degree alcohol, you can use any aldehyde except methanol. Okay, if you want to prepare 3 degree alcohol, you have to aldehyde, not aldehyde, you have to use here ketone. So this is the way to prepare 1 degree, 2 degree or 3 degree alcohol. So dear student, now I would like to identify 1 degree, 2 degree and 3 degree alcohol by using Lucas reagent. For the first time I would like to say what is Lucas reagent. Lucas reagent is basically the mixture of concentrated hydrochloric acid and anhydrous zinc chloride. So concentrated hydrochloric acid and anhydrous zinc chloride, the mixture is called Lucas reagent. Okay, for the first time if you want to identify 3 degree alcohol, you have to add Lucas reagent, this Lucas reagent with this 3 degree alcohol. As soon as you add anhydrous zinc chloride HCl concentrated solution, I mean to say Lucas reagent with this 3 degree alcohol, they produce white precipitation of 3 degree alkyl halide. This is so rapid reaction, this reaction happen rapidly. Okay, so you can as the white precipitation that is produced, if it is produced rapidly, then you will be sure of that there must presence of 3 degree alcohol. In case of 2 degree alcohol, if you use here Lucas reagent with 2 degree alcohol, they produce 2 degree alkyl halide, white precipitation of 2 degree alkyl halide, but it takes some time. It takes 5 to 10 minutes. If it doesn't take any time, if the reaction happen very rapidly, then this will be 3 degree alcohol. Okay, if to prepare white precipitation, if there need 5 to 10 minutes, then you will be sure of that this alcohol is 2 degree alcohol. In case of 1 degree alcohol, normally at room temperature, if you add Lucas reagent with 1 degree alcohol, there doesn't happen any reaction. Okay, there doesn't happen any reaction. If you heated this system, then 1 degree alcohol will react with this Lucas reagent, and by this way they produce 1 degree alkyl halide. Okay, 1 degree alkyl halide is not soluble in that solution, that's why the solution become turbid. Okay, from the turbidity of the solution, then you will be sure of that they produce 1 degree alkyl halide. So by using Lucas reagent, if you want to identify 1 to 3 degree alcohol, if the reaction happen very rapidly, then you will be sure of this reaction is this compound is a 3 degree alcohol. If the reaction happen, if the reaction to occur, if it takes 5 to 10 minutes times, then you will be sure of this is 2 degree alcohol. And normally if the reaction does not occur, okay, in that case you will be sure of that it may be alcohol, 1 degree alcohol. So this is the way to identify 1 degree, 2 degree or 3 degree alcohol by using Lucas reagent. So dear student, now different types of alcohol: rectified spirit, absolute alcohol and methylated spirit. What is rectified spirit? Basically 95.6% ethanol, 95.6% ethanol plus 4.4% water solution is called rectified spirit. Okay, absolute alcohol, the alcohol that is completely free from water is called absolute alcohol. This type of alcohol is basically 100% ethanol. The 100% ethanol is called absolute alcohol. Okay, this is completely water free alcohol. It can be produced from rectified spirit. By using this equation, this is possible to produce absolute alcohol from rectified spirit. Okay, this is rectified spirit, 96.4% ethanol and 4.4% water. If you add calcium oxide with this rectified spirit and if you carry out the reaction for 8 hours, then rectified spirit will be converted to absolute alcohol. Okay, now methylated spirit. Okay, methylated spirit is basically the methanol added rectified spirit. This is one kind of rectified spirit, but in that case methanol is added with rectified spirit. Basically methanol is added in that solution to make it not suitable for drinking. Okay, so methanol is added with rectified spirit to make it not suitable for drinking. Methanol added rectified spirit is basically called methylated spirit. At the end of the class, at the end of the lecture, dear student, you will be able to know about carbonyl compound. Okay, aldehyde and ketone, the preparation process of aldehyde and ketone, the identification process of aldehyde and ketone, number of information you will get about carbonyl compound, aldehyde and ketone. At the same time, you will be able to know about carboxylic acid, the preparation process of carboxylic acid. At the same time, the identification process of carboxylic acid. At the end of the class, you will be able to know about alcohol, about 1 degree, 2 degree, 3 degree alcohol, what is the preparation process and what is their identification process. In addition with you will be able to know different types of alcohol that can be used in industrially, commercially. Okay, so this is basically the information that I have focused in this lecture. Okay, thank you.